Today we are going to discuss how to manage multiple clusters using Red Hat Advanced Cluster Manager and Argo CD. Hey, what's up everybody? Welcome back to my channel. My name is Aleš Nosek and I am the software practitioner located in San Diego, California, helping you navigate the world of Kubernetes. Recently, I was working on a project for managing multiple clusters. The goal of the project was to manage both OpenShift and Kubernetes clusters. Although this can be accomplished in many different ways, the tools chosen for this project were Red Hat RHACM and Argo CD. This video will show you the core ideas of the solution. Let's discuss the big picture first. In this diagram on the left side, I'm showing a hub cluster, or also called a management cluster. The whole purpose of this cluster is to manage the other clusters. And on the right side of the diagram, I'm depicting managed clusters. Those are the clusters which are running your workloads, and they are managed by the management cluster. On the management cluster, which is a OpenShift cluster, we deploy Red Hat RHACM Hub. On the other hand, each of the managed clusters is running Red Hat RHACM Agent. In the case that the given managed cluster was directly deployed by Red Hat RHACM, in that case the Red Hat RHACM agent is also deployed automatically. In the case that you are bringing your existing cluster to be managed by Red Hat RHACM, how can you deploy the Red Hat RHACM agent on your existing cluster? Well, you go to your Red Hat RHACM Hub to generate a set of manifests, and after you apply those manifests to your existing cluster, the Red Hat RHACM agent will come up and will connect back to the hub cluster, and with that your managed cluster is ready. So after we attach a managed cluster to Red Hat RHACM Hub, we use Red Hat RHACM to deploy the GoDaddy External Secrets onto the managed cluster. We use GoDaddy External Secrets for managing Kubernetes secrets, and I will be talking more about the deployment of it in the next section of the video. Next, we use Red Hat RHACM to deploy Argo CD onto the hub cluster. We use Argo CD to configure the managed clusters, and Red Hat RHACM has one convenient feature. Whenever there is a new managed cluster attached to the hub cluster, the Red Hat RHACM will automatically add that managed cluster to the Argo CD's cluster inventory. So they just show up in Argo CD, and you can apply configurations to those managed clusters using Argo CD straight away. The bottom part of the diagram is showing our approach to Kubernetes secrets management. In our environment, we were already using HashiCorp Vault to manage secrets. So the question was, how can we use HashiCorp Vault to also manage Kubernetes secrets? And there is several ways how to achieve it. We chose to use the GoDaddy External Secrets operator, which is able to create Kubernetes secrets out of the secret data from HashiCorp Vault. So how do GoDaddy External Secrets work? The external secrets come as an operator which you deploy onto your Kubernetes cluster. And this operator will be watching a custom resource called external secret. So from now on, instead of creating secrets directly, you instead will be creating external secret objects. Now, the external secret, in comparison to the real secret, doesn't actually contain any secret data. Instead, it contains the reference to HashiCorp Vault, describing where the data, the secret data in HashiCorp Vault can be found. So with that, you can check in this external secret into your Git, and you can have even Argo CD deploy the external secret onto the cluster. Now, after the external secret shows up on the cluster, the external secrets operator will use the information from the external secret object to look up the secret data in the HashiCorp Vault, and based on that secret data, it will create or render a real secret in your Kubernetes cluster. So how come that the Kubernetes external secrets can just reach out to HashiCorp Vault and retrieve any secret data they need? Well, actually, before Kubernetes External Secrets can read any data from Vault, they have to be authenticated and also be authorized. In regards to authentication, the Kubernetes External Secrets currently only supports one authentication mechanism against HashiCorp Vault, and that's the Kubernetes authentication method. In order for the Kubernetes External Secrets to successfully authenticate against HashiCorp Vault using the Kubernetes authentication method, Kubernetes External Secrets must send a valid Kubernetes service account token to HashiCorp Vault. So the next question now is, where does Kubernetes External Secrets get this Kubernetes service account token? In our solution, we generate the service account token on the hub cluster because that is the cluster which is also hosting HashiCorp Vault. So the next problem to solve is how to distribute the service account token to all the managed clusters so that the external secrets operator running on those managed clusters can use that token to authenticate to the HashiCorp Vault. To distribute the service account token to all the managed clusters, we use RHACM. We take the service account token, which is a Kubernetes secret, and we wrap it into a RHACM object deployable. We then put this deployable into a channel of type namespace in RHACM. All our managed clusters do subscribe to this channel, and hence the RHACM will copy the service account token or on each of the managed clusters. As I said before, we also leverage RHACM to deploy the external secrets operator. And so when the external secrets operator comes up, it can just mount the service account token, and from there it can authenticate to HashiCorp Vault. Note that with this approach, we are copying the same service account token to all the managed clusters. Depending on your security requirements, this may work or may not work for you. As an alternative, you could configure your HashiCorp Vault to accept tokens coming from different Kubernetes clusters. In the configuration of the Kubernetes auth method, there is a parameter called PEM_keys, which allows you to specify your custom list of keys or certificates which will be used to validate the signatures on the service account tokens. This way, you would be able to validate tokens coming from different Kubernetes clusters. So finally, we are now ready to start deploying the multi-cluster management solution. And for that, you will need to first clone this Git repository, multi-cluster management RHACM and Argo CD Git repo. That one includes all the deployable artifacts we will be applying to the cluster. Next, you will also need an instance of RHACM. And on the same hub cluster where you install RHACM, you should also install HashiCorp Vault. In HashiCorp Vault, I have the key value engine enabled. And inside, I have two secrets. One is called My Cluster. This secret will be used later on when we will be deploying managed clusters. And the second secret is called My Secret. And inside, I have a test key with a secret value test value. And this key value pair here is used to verify the deployment of external secrets operator. And that's what we are also going to do next, deploy the external secrets. So I have the multi-cluster management RHACM Argo CD Git repository checked out. And by the way, I will also include a link to this repository down below the video. And the Bootstrap directory includes manifests, which we will need to deploy manually. Normally, there will be deployed using, for example, Ansible, but in this demo, we are going to do the manual deployment. So in order to deploy external secrets, we'll go to external secrets directory, and here a repo grep. I will take a look on two options which we need to replace, two settings here. So external secrets Helm up sub. So first we will need to insert our own endpoint, the Vault endpoint. So where is my Vault? I'll see, get route in the namespace Vault. So that will be the host name of Vault here. So I will insert it in this. All right, done. And the second manifest which we need to modify is the manifest which is bringing the service account token, which will be then later distributed to all of the managed clusters so that they can access Vault. Now, this token can be any token for a service account which is authorized to read secret data from Vault. In my case, it is the OCSA get token. It is the account in the namespace default, and the account is default. That's how I configured it in Vault. OCSA. All right, now before we put that token there, we need to base64 encode it. All right, so now I can take it and paste it in. All right, so paste it. Good. So now we are ready to deploy the external secrets. So we will apply OC apply -k all the manifests in this directory. So these manifests are mostly Red Hat ACM manifests, which will let Red Hat ACM install external secrets. This time we have only one cluster, which is the hub cluster in the deployment. So those external secrets will be installed there. Otherwise, any other cluster which we will add in the future, those external secrets will be automatically deployed there by Red Hat ACM as well. The deployment of external secrets takes just a couple of minutes. So let's take a look. How did it go? I will switch to the external secrets namespace because that's where we are deploying it. And I can take a look at the pods which are running here. So that's the external secrets pod here. And then I have a test secret which I created in this namespace, or let's say the manifests which we deployed before, they created that external secret here. It's meant for testing. So I will get, you can see it sitting here. I will also show you how it looks inside. So this external secret, that's the object which the external secrets operator is watching. And in here, we have an external secret which is referring to the location of a real secret in Vault. And that location is under kv data my secret. So that will be the location which I showed you before in Vault, where the test key value or test key had a value test value. Now you can see that the test value is nowhere here because external secret object doesn't really contain any secret data. But based on this object, the external secrets operator should have created a real Kubernetes secret. So let's take a look. That Kubernetes secret will have the same name. So that should be the external secrets test. And you can see it's here. So let's check it out. OC get secret. So you can see that in that secret, there is a key called test key. And this value should be the test value. Yeah, it is. So it looks that the deployment of external secrets succeeded. Next, we are going to deploy Argo CD. And for that, we need to go back to the Bootstrap directory. Argo CD is distributed by Red Hat as a part of the OpenShift GitOps add-on. So we are actually going to install OpenShift GitOps. And so for that is OC apply -k the GitOps operator here. Okay, so first we will need to create a namespace. I forgot, so GitOps namespace. And after that, into that namespace, we can deploy the subscription, which will deploy the operator. All right. And let's switch to the OpenShift GitOps namespace where the Argo CD will come up. Okay, it's still in progress. Still in progress. All right, I guess I will pause the video here and come back in a minute. All right, so it really just took 1 more minute for Argo CD to show up. So if I list the pods now, I can see that the Argo CD is running in this OpenShift GitOps namespace. And I can take a look also where is the Argo CD endpoint. So I can log into Argo CD at this host name, at this host, and then I will also need credentials to log in, and those are stored in one of those secrets here. I think that's the Argo CD cluster secret. Okay, I'll get it out. That's the admin password here. And if I decode it, decode it, then this will be my password, which I will use when logging into Argo CD as user admin. Let's take a look where we are right now. We have one OpenShift cluster with RHACM running on top. If I go to the cluster view, you can see that there is this really one local cluster. And then we used RHACM to deploy the external secrets as well as the GitOps operator. External secrets graph, deployment graph looks something like this. And the GitOps operator looks as follows. Let's take a look at the GitOps operator Argo instance. As you can see, there is no applications deployed yet here. But if we take a look at the cluster inventory, we can see that the local cluster has been already imported to here by RHACM. So at this point, we have our multi-cluster management solution ready. And in the next part of the demo, we are going to finally manage the clusters, configure them, as well as deploy one more cluster. So what are we going to do? We are going to apply one more customization from the Bootstrap directory to the hub cluster. And this customization will create RHACM subscription object on the hub cluster. This subscription will instruct RHACM to reach out to the same Git repository and pull additional manifests and apply them to the hub cluster. What are these manifests for? These manifests will actually create Argo CD specific objects. So for each managed cluster, we will have one Argo CD application project. So you can see at the top here that we have a local cluster application project. So that one is the project which manages local cluster or also hub cluster. And we have one more Argo CD application project, my cluster, which will include configurations for the my cluster, which is the cluster we are going to create in just a second. So let's now discuss the Argo CD applications which pertain to the local cluster. The first Argo CD application, local cluster config, will instruct Argo CD to reach out to the same Git repository and pull several manifests and apply them to the local cluster. Now these manifests actually include various configuration for the local cluster. So for example, we are going to modify the API server object on the local cluster, and there are several other configuration manifests we would like to apply to the local cluster, which you can find in the Git repository. The second application, called local cluster deploy my cluster. So this application will create several objects on the local cluster. And these objects are RHACM specific objects that describe a deployment of my cluster. So after Argo CD creates these objects on the local cluster, Red Hat ACM will reconcile these objects and trigger the deployment of my cluster. After the deployment of my cluster is complete, my cluster will connect to Red Hat ACM Hub, and Red Hat ACM will add this my cluster to the Argo CD cluster inventory. Finally, Argo CD will be then able to sync this my cluster config application, because the cluster showed up now, and this my cluster config application will configure our my cluster with all sorts of different configurations. For example, we will again modify the API server configuration, but there are several other manifests we apply to the my cluster to configure it. So let's give it a shot. I will go to the Bootstrap directory and go to Argo CD apps, OC apply -k, this directory. And let's see in Argo CD what is happening now. So we are back in the Argo CD dashboard. Let's take a look at the applications. You can see that there are several applications already created and syncing. So we have some errors here as well. Okay, Argo CD thinks that the local cluster object doesn't exist yet. Of course, the manifests are synced in random order, so it will take a bit before the projects will show up. Okay, we have them here, so Argo CD is happy now, and Argo CD immediately synced up the entire local cluster config application, so it's all synced and it's all healthy. So all the configuration manifests here are successfully applied to our local cluster. Let's take a look next. We can see that the second application here, local cluster deploy cluster, is still syncing. And I will pause the video here because that may take a while. Oh, actually it's already going. All right, looks pretty working, making progress. So this local cluster deploy my cluster creates all the deployment objects, and this will then trigger the deployment of the cluster, which is done by Red Hat ACM. So let's check out on the console if the deployment of my cluster already started. So the deployment of the cluster is done by Red Hat ACM component called Hive, and Hive, for deploying the clusters, creates a job when it is deploying. I don't know where the job is, but I don't have that many jobs running on this cluster. So if I check all of them, okay, so this must be this provisioning job running in the my cluster namespace. Okay, that makes sense. So OC get pod in that namespace. Let's take a look at all the pods in there. Okay, so this my cluster pod is now provisioning the cluster. It is running the OpenShift installer. And it looks a little bit scary that the pod is not ready yet. However, it is actually by design. When the cluster is provisioned, the pod will turn ready and complete. So that's normal that you see not ready. So let's check out the provisioning logs here. So OC, I'll maybe switch to that namespace first. All right. OC logs -f. Okay. There are several containers running in that pod. I'm not sure exactly which one is actually running the installer. So let's check all of them. Okay, not this one. Not this one. Okay, so probably the last one. Yeah, that looks good. So yeah, here you can see, I will scroll up a little bit here. Oops. So you can see that we are running the OpenShift installer with the debug option, so we get really verbose logs. And there anything interesting? Install ID. Yeah, the standard IPI installation of OpenShift on AWS. Goes down. I will jump to the end. At the end, we are now waiting for the bootstrap of the cluster to complete. So in the meantime, before the bootstrapping and the cluster is up, let's walk through the code actually, which deployed all those manifests and created also this cluster. So here I have the code of the multi-cluster management Red Hat RHACM Argo CD GitHub repository. And when walking through it, let's stop first at the bootstrap directory. So this is the directory we were working with today, and that's also the root of the entire project. So from here, we deployed external secrets. We created the GitOps namespace on the hub cluster. Then we deployed the GitOps operator, which is the Argo CD. And as a last step from here, we created the Argo CD project and application definitions. Next, let's take a look at the Argo CD applications. So as you can see, we organized those applications based on the cluster they pertain to. So if I look at the applications for the local cluster, you will find the two of them here. So that's the local cluster config application and local cluster deploy my cluster application. So if I click on one of those, you can see here how we prefer to set the sync policy for all of our Argo CD applications. We prefer to set the prune to false. This is our preferred settings because it's a little bit more safe to work with this. If your manifest for some reason disappears from Git repository, or it is maybe moved by accident, Argo CD is not going to just delete all those resources from the cluster right away. Because the prune is set false, Argo CD will just mark those resources for pruning, but you need to trigger the pruning yourself. So that's what we prefer. The second option here, the self-heal true option, will configure Argo CD to try to sync this application forever. It means if the sync fails, Argo CD will just keep trying until finally the state of the application in the Git repository and the deployment on the cluster is in sync. This is something what we prefer because it allows us to apply the manifests in any order, right? We don't need to think about the order of the manifests as they are applied by Argo, because eventually Argo CD will succeed because it will just keep trying. And also if there are failures outside which caused the sync to fail, then again Argo CD by the next time will finally sync. And this is also the behavior, this endless trying to reconcile the cluster state. This is also the behavior which we are used to from OpenShift operators. In this application definition, you can also see that we are pulling the manifests to be applied by Argo CD from the same Git repository. And the next step to go is the path aggregates local cluster config. So let's take a look there. The aggregates directory, you can find it here. We use that directory as for the organization purposes to really organize those different manifests and customizations. We use the aggregates to put in the top level customizations, which are then including and pulling in further customizations down the road. So if I look at the local cluster config customization, you can see that it just consists of several bases, which are the high level pieces or blocks of configurations which we apply to the cluster. Also, when we see the aggregates, we can easily see and compare, right, what configurations from the high level standpoint are applied to each of the clusters. From the aggregates directory, we can now go down the manifests hierarchy. In the manifests directory, that's where we store the bottom level manifests, customizations, and overlays. One thing interesting here is maybe the way how we manage resources on the cluster which are not owned by Argo CD. That means resources which were not created by Argo CD, and we want to use Argo CD only to modify them. So an example of such a resource is this API server definition here. I spoke about it before, that we set all Argo CD applications with the disabled auto prune. So that's the first step. However, still, when this resource will be removed from Git and the user after that would run a sync with the prune option, then Argo CD would still try to delete this resource. So to avoid the pruning for this resource, even under this condition, we set this an Argo CD annotation here with the prune equals false. So that ensures that when this resource is no more in Git, we removed it from there because maybe we don't want to manage this resource in Git anymore. Then even after a user syncs up the application with the prune option, Argo CD will not try to delete the API server resource from the cluster. In the meantime, the cluster deployment is complete. You can see that the deploy my cluster application is all healthy and synced up. There's a lot of resources deployed here. So that is done. If we take a look at the applications overview, the last application, my cluster config, that was the application which was supposed to configure my cluster after the deployment was finished. So that one is now synced up as well. So everything is perfect. In the last part of today's demo, I would like to show you how you can remove resources from the cluster and also remove them from the Argo CD management. So as an example, let's take the two resources here. So first, the API server resource, we would like to remove that one. And also this cluster viewers group resource, we would like to also remove that one. There is one difference between the two resources. While the API server is a resource which is marked with the prune false annotation and should never be deleted by Argo CD, the cluster viewers group resource doesn't have this annotation, and we actually want, when we remove this resource from Git, we would like Argo CD to delete this resource. The first step, how to remove the resource from the cluster, is to delete it from Git. So let's do it now. For that, I will go to the aggregates directory, and it was the local cluster we want to work with. So in the aggregate customization here, I happen to know that this one line here is holding the API server resource. So if I comment it out, Argo CD will not see that resource anymore as being in Git. And the users base here, that's the one which is holding the group resource here. So I will also comment it out as well. We'll commit the changes and we'll push it to the remote Git. So now let's go take a look what is happening in Argo CD. In Argo CD, we can now see that there are 3 resources out of sync. The first one is the API server, which is expected to be out of sync because we commented out the line, and hence Argo CD cannot see this resource in Git anymore. So that's why it's out of sync. The same holds for the resource of type group, cluster viewers. That one also is not visible to Argo CD anymore. And the third resource here, which is the cluster role binding, was actually along with the group resource part of the same customization. So because I commented out that one line, both of the resources are no more visible to Argo CD as being in Git. And so that's why they're out of sync. The next step is to remove the resources which can be pruned, remove them from the cluster. For that, I will just run a sync operation with the prune checked. So Argo CD now will remove all the resources which are no more in Git. It will delete them from the cluster. However, if it sees an annotation on the resource prune false, then the resource won't be deleted. And that's exactly also what happened here. As you can see, the API server resource is still out of sync, and it was not deleted from the cluster. How can we make Argo CD forget about the API server resource now? We will need to go and look at the live manifests, and you can see that the API server resource is labeled with this Argo CD label. That tells Argo CD that this resource is under management under the application local cluster config. So what we need to do now is just remove this label from the live resource. For that, I will edit this live resource here. Just remove it from the object, save it. And from now on, Argo CD completely forgot about that this object ever existed or was managed by Argo CD. And we are again fully in sync with our application. We covered a lot of ground in this video. We started by reviewing the deployment diagram. In the diagram, we have seen the 4 building blocks of our multi-cluster management solution. Those building blocks are Red Hat RHACM, Argo CD, HashiCorp Vault, and Kubernetes External Secrets. We also reviewed the secrets management. We've seen Red Hat RHACM in action, deploying a new managed cluster. And we've also discussed how to manage cluster configuration using Argo CD. I hope you enjoyed today's video. Please feel free to leave your questions or comments down below. If you found this video helpful, please consider subscribing so that you are notified whenever I release a new video. Until next time.